Welcome, everybody. Scott Jaeger, introducing the new Bionic Lester. Yeah.
Hi, I'm Scott Jaeger of Industrial Music Electronics. I'm here at Modular 8 in Portland, Oregon. Thanks to Phil for bringing me here. I have my new module, the voltage-controlled filter, Bionic Lester Mark III, to demonstrate today. So, on the video screen here, you can see the outline of this module. It's a dual filter with similar sets of controls on the top and the bottom, with the I/O at the very bottom and the preset manager beneath that. If you look closely at the faceplate, you may notice a few new things that you may not be used to. The differences are very subtle. I have revised the typefaces on the faceplates just a tiny bit to get a little closer to the ideal. Now, if you're familiar with the industrial music electronics design language, the very bottom of each faceplate has the module's identity and model number declared in Helvetica. Obviously, one of the most popular fonts of the 20th century. I've recently felt that font is not enough to properly communicate the weight of these model numbers. So let's go back a bit and examine a usage of the Helvetica font. Maybe a bit before my time, the mid-1970s, imagine a public utility or organization or service with a signage and a bold weight of Helvetica. Let's take, for example, the blackmail agency, that on which you reluctantly depend and must keep your appointment, where they believe in treating everyone as an individual, even if everyone eventually gets the same treatment. But this signage does not come across as very convincing, does it?
No.
Let's go to a heavier weight, a medium. We're kind of getting there. But still, you could go farther. And now it looks like it should be in wood up on the side of the building, and that which would compel you to enter the door and keep your appointment. This is Helvetica Bold here at the bottom line, which I have previously used on most of the Mark II and III faceplates. I've since made a better change to the British Rail alphabet, which itself is derived from Helvetica and similar typefaces. But the bowls and the crotches and the extenders are all tightened up a bit to offer maximum area of blackness in the type so that visual communication at a distance is much more clear, much more authoritative. We have some examples of this type with the old Helvetica on top and the Rail alphabet on the bottom. You can see where the bowl in this lowercase a has been tightened up considerably under the new scheme. The tracking has also tightened up in these uppercase titling examples. More examples here, where you can see that the crossbar on the A has been lowered a little bit to give it a little bit more space. Same with the crotch of the uppercase V there. Most importantly, the numerals are quite a lot clearer. You can see the numeral 1 down here in our new Braille alphabet font, where the unnecessary curvature has been eliminated. And you can see it most conspicuously in the 7s, where we have no curvature whatsoever in the descent. I made one more change to our font from the neo-grotesque that shall not be named that everyone uses these days. I'm sure it looks familiar with its blown out tracking. I found a nice substitute a few weeks ago, and it took a long time to identify it. I found it in a late 60s Mad Magazine paperback, but I was unable to identify the font for several hours because the things that I liked very much about it were, in fact, alternates in the character set. So I'm sure many of you are familiar with this guy on the top line. Has since been replaced with good old Director's Gothic 230 with certain alternates in play at all times. If you see this S, the spine is completely horizontal, which is, as I found, it's a really rare feature in this class of fonts. There's a nice little swash on the end of the R, and the tracking from letter to letter is at its most sensible. Anyways, the Bionic Luster faceplate features these upgraded typefaces, as well as the most recent run of Hertz donuts, and the Piston Honda will soon follow suit as well. I hope it aids in the legibility of the functions during your learning period of the module. So, getting to the Bionic Luster. Bionic Luster is a dual voltage controlled filter, 100% digital. It has 2 audio inputs. One is normal to the other for easy parallel routing. The inputs have an overdrive and a saturation. There are individual outputs as well as a mixed output with a little knob to control. So, I'm going to bring up a simple wavetable sound using the Piston Honda wavetable oscillator, and I will play a few low-pass filter sounds in classic style. Now, we are going to listen to the Piston Honda's wave morph with and without the Bionic Luster overdrive. Here's what it sounds like when it is clean. You can hear the small jumps in amplitude as I morph from wave to wave, and that becomes more important when the overdrive is in play. With the gain control at 0, going up to noon, it simply acts as a gain control. But if you go beyond that, soft clipping comes into play. And beyond that, the clipping becomes harder. This overdrive is always pre-filter, so if your input signal is deficient in harmonics, you can always add just a little more. It's not an ultimate tool of destruction, it just adds a little bit of hair to the signal for filtering later. But Bionic Lester is not a simple low-pass filter. The small knob on the left side of the module in each section allows you to continuously control the mode of the filter. It's a smooth crossfade from low pass over to band pass, then high pass, to notch, and then to the comb filter mode. So I'm going to play the same sound as we test it with varying cutoff frequencies at different modes. You can see the mode on the display here with a little needle that moves as the mode changes. So now we'll listen to the band pass and continue onward. And that's our notch filter right there. So, Bionic Lester has two filter sections that can be run completely independently. It has an A input, B input, likewise for the outputs, as well as a mix. The A input is normal to the B for parallel routing. So let's take the same signal into A and B and explore the modes of linking the filters together. Now our patch is set up in stereo, with the output of filter A going to the left speaker and the output of filter B going to the right. So this link button here shows how the different filters, signal, and the control paths can be connected together without any additional patch cords. The first is the A control. A control, with respect to filter B, it takes the control signal coming from A, that which defines the cutoff frequency, and copies it to B. But then the B controls, such as the big knob and the CV input, allow you to make an offset from that. So this is how you achieve a popular dual peak stereo bandpass effect, where the peaks move at the same time but with some distance between them. The distance being determined by the amount of offset in the B knob. The next filter mode is series. In the series mode, the control paths are completely independent. What you program with the CV inputs and your fingers on the knobs, one filter would not affect the behavior of the other. Instead, the output of filter A is digitally routed to the input of B, so you don't have to use a short patch cord to achieve series effects. This mode is useful for constructing elaborate arrangements of distortion with precision filtering of unwanted products. So let's listen to filter B exclusively, as that's the output of our series. Okay, we have two filters in series now. So let's make the output of filter A very distorted and then calm it down a bit with filter B. And there, you can hear the intensity underneath that filter cutoff. Go up an octave to be friendlier to the speakers. Next filter mode is 4-pole. Like the series mode, it has the digital routing of the filter A output to the B input. It also has the entire control arrangement of filter A, being the mode selection, the resonance, and the cutoff frequency. All of that is directly copied to filter B with no offset. So you essentially have a 4-pole filter, which is two cascaded 2-pole sections. In this mode, of course, you have the two distortion sections cascaded together, so the distortion products are much more violent at the higher end. So I will demonstrate again the effects of the wave morph while the cutoff is open with double the intensity. Here it is with no distortion. And now we'll add some clipping. The last of the link modes is called stereo. In this mode, there is no routing from output A to input B. You have a completely independent signal path on the A and B channels. Instead, you just have the controls of A copied to B as before, but with the ability to add a little offset from the B controls as we did in the former A control mode. So this mode is great for, again, doing your stereo bandpass offset cutoff effect. And it's a bit easier to do when you have the A controls predominating over the B, which adds a small amount of offset. So I'll turn it to bandpass so we can hear some more of this effect. I recently took the nearly finished prototype of this module to demonstrate at KnobCon, the world's only synthesizer convention. And while I was there, a good friend of mine, Zach, who makes some great videos for these modules, he had the idea, what if Bionic Lester had a comb filter? Once upon a time, there was a straight-up all-pass mode on the Bionic Lester, but it was a bit underwhelming compared to all the other modes that I've just demonstrated. So I thought about it that weekend, and I thought of a way to cleanly implement the filter in a short amount of time that worked well enough for the application, and it was good. It dramatically changed the focus of the module if you dial the mode further to the comb setting. So we're going to listen to one section of All Pass. There's our sound. The display and the mode setting reads AP for All Pass. It's at All Pass when the resonance control is at 0. When you change it all the way to All Pass, the cutoff frequency display stops telling you what the frequency is in hertz, and instead it tells you the length of the delay line in samples. So you can smoothly modulate this at a low speed. So you can hear the modulated all-pass delay line smoothly going back and forth. It sounds good as long as you don't modulate it too fast, because then you're skipping into unknown regions of the buffer. So if you use your imagination, you can use a single Bionic Lester to have two all-pass lines of varying length. You can use it as a diffusion network or as a building block to a reverberation effect. You can often achieve much more interesting results if you roll your own, so to speak. And as you turn the resonance up, it changes from an all-pass filter to a comb filter. We've taken the modulation away, so now it's a static length of delay line. As you turn the resonance up, there are two different flavors of comb filter that you access in this mode. The first is the positive feedback. Turn that up and pick a sound with some harmonic content. Yeah, it sounds like a comb filter. As you turn the resonance up some more, it starts to feed back on itself and you get interesting harmonic evolutions. If you hold the delay line constant. If you use a stepped voltage to change the length of the delay line, you can get these little nodes that develop every few seconds and then reform again with each voltage change. When you turn this resonance control past the noon position, it switches to negative feedback, a slightly different class of effect, but with similar behavior. The positive and the negative feedback processes often select different portions of the input signal spectrum to develop into shifting waves of feedback. As you take the feedback to the maximum, that is where we again get the developing self-cycling feedback. I'm now going to pan both outputs hard left and right and bring in some other cone filter feedback from the B channel. So that demonstration was a very slowly moving step voltage from a Stilson-Hammer sequencer, selecting a new length of delay line every few seconds. So the breathing room in between allows the feedback to develop into new harmonic arrangements. As I started the sequencer, I no longer had to manipulate the wave shape controls on the oscillator. All the changes you were hearing were just coming from the internal feedback in the comb filter. Now, Bionic Luster is a purely digital filter, yet in its low pass and band pass and other normal modes, it exhibits a nice strong character that one would normally associate with more analog designs. This filter was inspired by the design of virtual analog synthesizers in the late 1990s with brightly colored paint jobs. I liked the Microwave XT and the Access Virus filters the best, so I thought a lot about the overdrive characteristics of those filters as I started to design. The Bionic Luster filter itself is pretty simple two-pole state variable topology. The secret sauce comes from strategic placement of overdrives within the filter's signal path. And it's resulted in a character that I like quite a lot for normal velocity-sensitive envelope low-pass filtering duty. I don't really miss analog filters a whole lot since finishing this. Now, Bionic Lester has a preset manager that stores 8 complete states of the module. So all your knob positions, all your CV input assignments, all that is stored and very quickly switched back and forth using the preset controls, whether you're clicking the knob or using an external control voltage. More so than the other Mark III designs, the Bionic Lester design is almost entirely modeless, continuous control between all the parameters, so that you may achieve very smooth morphs between the presets in the morph mode. So I'll bring up our sound again. Now we'll click through the 8 different presets. Now we'll give it a control voltage to switch. So we're switching between a bunch of filter configurations here. And we will turn on the morphing mode now to achieve the smooth transitions in between. You only get 2 sections of filter using one of these modules, but you can still achieve some nice vowel effects by using the bandpass mode with high resonance and the preset morphing to move those peaks around wherever you want them to go. There once was an older filter module also named Bionic Lester, released by a company named the Harvestman Digital Audio Electronics in 2011. This filter isn't related to it too heavily. That first Bionic Lester, referred to as the Mark I, was a modularization of a switch capacitor filter chip by Maxim, the Max 263. Switch capacitor filters are interesting because they are discrete time systems, despite being more or less continuous in output voltage. So they exhibit the property of aliasing if you don't keep your driving clock frequency high enough. Now, the original Bionic Lester, the Mark I, did exhibit that kind of behavior. So you took the cutoff frequency down into the hundreds, tending towards 0, you would hear the crunch, the bit crushing develop into the signal. This Mark III version does not have that behavior. The Mark I did have several nice flavors of overdrive, some of which are hinted at by the Mark III's overdrive behavior. But I would consider this new Bionic Lester to be a completely new design. As for what happened to the Mark II, It was a design exercise of mine that also used a switch capacitor device, but I was not able to make it work properly to my satisfaction, and the resulting device would have been very expensive. So it was abandoned and replaced with this new all-digital design, which I hope the character is satisfying in comparison to the old one. The Mark I also had some other disadvantages, such as the resonance control was not independent per filter. You picked one value and applied to both of the filter sections. It also did not have a long delay line for effects like the comb filter. It did have a nice weird all-pass with some good distortion, but we are concerning ourselves with this new device today. Hereafter regarded in the flesh with a new dread bordering on respect. I've also brought a prototype of a new device with me that I've been threatening to release for a few years. It is called Volkmeyer's Inferno, and it is a granular synthesizer meant to perform equally well under live input or file playback situations. It takes your input audio and considers the input buffer as a field from which several dozen grains of audio are picked and enveloped and overlaid and played at various speeds to create a thick cloud of sound. So I'm going to load up this audio file of Axl Rose singing, and we are going to granularize it in various ways with a specific focus on the independence between the apparent pitch of the signal and the playback speed as the playhead scans through the audio buffer. So that's what the file more or less sounds like without any modification. So I'm going to mess with the density of the grains and also the number of the grains. Then afterwards I'm going to pull the playback speed down a little and then mess with the pitch. I'm well into the development of this module, and the full user interface will be revealed shortly. But for now, I thought I'd play some of the sounds that it's capable of doing. So, submitted with these findings of law, findings of fact, and conveniences of law contemporaneously herewith. This is Volkmeyer's Inferno, the granular synthesizer. And here we are listening to the Bionic Luster again. So if anyone has any questions about how these devices work, I would like to answer them at this point. Yes, Phil.
How do you get into the morphing mode on presets again?
Okay. Question from the internet. How do you get into the morphing mode on the presets? Every Mark III module has an illuminated button near the display. And as you push it, it'll illuminate. When it's illuminated, it'll say either preset or morph in the display. When it's active, you use the rotor encoder to dial in your preset. If you want to edit that preset, click the encoder again, turn the knobs to your liking, click the edit mode off. Now it's locked in again. Morph mode works a little differently. When you're in morph mode, it takes over the control of most of the knobs on the panel. You still select the bass preset, but all your action is going to come from the control voltage that you put into it. Then you click it again to exit out of preset mode, and you're back where you started with your manual control.
And the cone filter run through. That's one of the mode. You go to all passive.
Okay. All right, so the way that the comb filter works and how you enter that mode. If you watch on the display right here, the small knob for each of the two filters controls the mode continuously. At the fully counterclockwise position, it's low pass. Then you take it up to band pass. Noon is high pass. There is the notch filter. When you take it past notch, you begin to enter the all-pass mode. It's either all-pass or comb filter when the knob is fully clockwise. When resonance is 0, it is all-pass. When in all-pass or the comb modes, the cutoff control instead changes the length of the delay line. Now as you turn the resonance up towards noon, that's your positive comb filter feedback. As you get right up there at noon, that's when the feedback starts to regenerate. Turn past noon and you're back at low resonance, but now the comb filter feedback is negative, which will generate different sets of harmonics depending on the characteristics of your input signal. The Bionic Luster has been successfully manufactured, so I'm accumulating stock right now, and I suppose they'll start shipping to dealers at the end of next week. In any case, it's very soon now. The module works and sounds great, and we're now in the process of simply accumulating stock. Nothing from the internet. I do have a few of them with me, so if you're interested in obtaining one before they ship out to stores, you should talk to Phil today.
Are the modes CVable?
Yes, the control is continuous. The way the CV inputs work is you have two high-speed ones that are dedicated to cutoff frequency that respond nicely to fast, snappy envelopes. But if you enter the menu, both filters A and B, you can assign the second and the third CV inputs to whatever destination you like, whether it's another cutoff modulation, or the resonance, or the input gain or distortion, or the mode. And it must be said that the zero crossing detection's pretty good on the gain and the distortion modulation. However, due to the complexity of mixing some modes together, you may encounter a bump here and there if you're modulating the mode quickly with a continuous CV that you may not expect otherwise. Bionic Luster Mark III is 15 HP. The granular synthesizer is named Volkmeyer's Inferno. The warrior's torso is almost fully developed.
What were the influences on Volkmeyer's Inferno? That's a question from the internet.
question from the internet. What were the influences on Volkmeyer's Inferno? Obviously, if you ever tried to pass the turbo tunnel during a game of Battletoads, that's a direct reference to the title of the module. As far as the granular synthesizer content, well, some time ago I really got into the works of Barry Truax, Wings of Nike, River Run, some of his work going into the 90s. He had very well documented these pieces. I once did the DVD supplement to a book about the analysis of electroacoustic music, and the chapter that I liked working on the most, of course, was River Run. So shortly after the publication of that book, Barry had made some DVDs available showing spectrograms, other analyses, and of course octaphonic audio files of some of his pieces there. So I obtained that from him, and I took his late 70s, early 80s specifications of his implementation of granular synthesis, and that was a good starting point to explore Volkmeyer's Inferno. As far as the lengths of grain and the hold times of the envelopes, those were really good starting points, and they lent themselves well to dense clouds of sound that without too much overlap in there. So yeah, that's what got me thinking about the concept, his work in particular, and I've since expanded on it other ways. The finished module has a few hotkeys for, you have your typical controls like pitch, speed, density, number of grains, your loop points, but there are also hotkeys that will modify the function of the controls. For example, if you hold down the random key, that will introduce some random variation into each control as each new grain is generated. Likewise with the shift or the alt key. If I put a dedicated knob on everything that was possible in the module, it would be something like 30 HP. It would cost $650, and it wouldn't be very much fun to play in a live situation. So the interface is condensed down to 18 HP. It is optimized for getting sounds quickly off of your SD card or out of your input, chopped and looped quickly, and then the three big knobs in the center determine the parameters of your granularization. And then up top you have your volt per octave conforming pitch and speed controls. And of course there is an OLED display with morphing preset manager, just like everything else these days. I couldn't say anything. The Bionic Lester, MSRP in the United States of America is $475 US. There was nothing I could do about that.
Well, anything else? Any questions? Fonts? That was interesting, actually. Thank you very much. You leave it now, or do you have time to?
I'll hang around for a little bit.
All right. Thanks. Oh. Thanks everybody for coming, and particularly those guys on the internet. We broadcast all this shit live all the time, but nobody ever tunes in, so it's good to see people on there. And this will be archived up on our YouTube channel. I'll get to editing them in a bit. So thanks again, and see you next time.
Yeah. I paid the £100 for the font.
Wow.
I only got one blade of it though.
I did too. Norman is here. He's it's like what got into graphic design, I think. Fonts. I like that's interesting. Actually, somebody bought one of these. So I was watching us. I just invoiced them, so we need to buy. By the way, Volkmeyer's Inferno. I had never heard of Barry Truax. So that was really interesting.
He's a
the guy over
Fraser up in Canada. He's academic electroacoustic composer, but he was the guy that first did the first real-time implementation. This shit heard a million times before. The first real-time implementation of granular synthesis.
That's River Run and Wings of Night.
Those are good. Those two are really good. But there's
It was 86 and 87.
there's one. River Run was 86. Wings of Nike it might have been 85. I can't remember the exact dates. But there's also one he did. There's one. Pacific might be the other piece that's really good. There's one CD they did like 4 environmental pieces that use ocean sounds, and like 3 out of the 4 tracks on it are amazing. I'll send you a link.
I've gotten through part of Curtis Rhodes and Mike Carson.
Yeah.
That's another one.
Yeah, he gets really deep with
That
it.
thing, and then compute